Alright, so in this problem, I have 25 to the power of x plus 5 to the power of x is equal to 20. So I'm going to first start by rewriting 25 to the power of x as 5 squared to the power of x. So I simply just substituted in 5 squared for 25. And I have this plus 5 to the power of x is equal to 20. Now, if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of n to the power of m, meaning I can switch these two exponents. So this is the same thing as 5 to the power of x to the power of 2. And I have this plus 5 to the power of x is equal to 20. Now I'm going to let 5 to the power of x equal to the variable y. So now if I substitute in y for 5 to the power of x, I get y squared plus y is equal to 20. And now I'm going to simply subtract 20 on both sides. So then these two cancel out, and I get y squared plus y minus 20 is equal to 0. Now I'm going to rewrite y here as 5y minus 4y. And I'm going to factor this by grouping. So first, from y squared plus 5y, I can factor out y, so I get y times y plus 5. And from negative 4y minus 20, I can factor out negative 4, so I get negative 4 times y plus 5. Now if I factor out y plus 5 from this, I get y plus 5 times y minus 4 is equal to 0, meaning y is equal to negative 5 and y is equal to 4. Now remember how we said that 5 to the power of x is equal to y. So to start, we have 5 to the power of x is equal to negative 5, and you can't take the power of a positive number and make it negative, so this is wrong. Now for y equals 4, we get 5 to the power of x is equal to 4. And to solve this, I'm going to take the log on both sides. So I get log 5 to the power of x is equal to log 4. And if I have something in the form log a to the power of b, I can move this exponent of b to the front. So it's going to equal b times log a. So in this case, I have log 5 to the power of x, and I can move x to the front. So I get x times log 5 is equal to log 4. Now if I divide both sides by log 5, these two cancel out, and I get x is equal to log 4 over log 5. Alright, so in this problem, I have 8 to the power of x plus 2 to the power of x is equal to 68. So to start, I'm going to first rewrite 8 here as 2 to the power of 3. So now I have 2 to the power of 3 to the power of x plus 2 to the power of x is equal to 68. And I can actually switch the places of the 3 and the x. So this is the same thing as 2 to the power of x to the power of 3 plus 2 to the power of x is equal to 68. Now, I'm going to let 2 to the power of x equal to the variable y. So now I have y to the power of 3 plus y is equal to 68. And if I subtract 68 on both sides, I get y to the power of 3 plus y minus 68 is equal to 0. Now, 68 I can rewrite as negative 64 minus 4. And now I'm going to change the order to y to the power of 3 minus 64 plus y minus 4 is equal to 0. Now 64 is the same thing as 4 to the power of 3. So I have y to the power of 3 minus 4 to the power of 3 plus y minus 4 is equal to 0. And if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So in this case, this can equal y minus 4 times y squared plus 16 plus 4y plus y minus 4. And now if I factor out y minus 4, I get y minus 4 times y squared plus 16 plus 4y plus 1. And this is equal to y minus 4 times y squared plus 4y plus 17 is equal to 0. So now this gives me two equations. I have y minus 4 equals 0, meaning y equals 4, and I also have y squared plus 4y plus 17 is equal to 0. And if you end up using the quadratic formula in solving this, you get the square root of a negative number, and you can't take the square root of a negative number, so this is wrong, and y equals 4 is my only solution. Now remember how we let 2 to the power of x equal y. So now we have 2 to the power of x is equal to 4, and 2 to the power of what equals 4? 2. So I get x is equal to 2, and this is my solution. Alright, so in this problem, I have 9 to the power of x minus 1 is equal to 3 to the power of x. So obviously, I want to find the value of x here. So for my solution, I'm going to first start with writing my equation. So 9 to the power of x minus 1 is equal to 3 to the power of x. And now, I'm going to rewrite 9 here as 3 squared. So I have 3 squared to the power of x minus 1 is equal to 3 to the power of x. And the reason I did that was because now these two have the same bases. Both the bases are 3. So now it's going to be much easier to solve. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So in this case, I have 3 to the power of 2 to the power of x minus 1, and we can think of 2 as m and x minus 1 as n. So this is going to be the same thing as 3 to the power of 2 times x minus 1, and which is equal to 3 to the power of x. Now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, 2 times x minus 1 is equal to x, meaning 2x minus 2 is equal to x, and x is equal to 2. So that is my answer.